because this concept or this topic cut across almost everything in chemistry. So, and that has to do with naming of organic compounds. So, sorry, naming of inorganic compounds. So, we want to look at the basics of naming of inorganic compounds. So, that is the topic of our discussion. Few seconds, please. I hope you can see the screen.
Yes, sir.
Okay. So, in the last class, we looked at naming of organic compounds. So, today we are looking at some basic rudiment of naming inorganic compounds. So, on a general scale, we want to limit our explanations majorly on the naming of ionic compounds. Okay, namings of ionic compounds, and also the naming of um, molecular compounds. Sorry, let me rewrite that. Let me change my ink. I don't know why it is not writing properly. Few seconds, please. I hope you can hear me, everybody.
Yes, sir.
Okay. Molecular compounds. So here we are majorly talking about covalent compounds. Okay. So that is what you want to do majorly for today. So we want to learn how to name ionic compounds, what are the rules in naming ionic compounds, and what are the rules in naming covalent compounds. So this will take us through the next 1 hour or 30 minutes or thereabouts for us to complete this concept. So this concept will assist us in writing chemical equations. It will assist us in stoichiometry, and it will assist us in so many things in inorganic chemistry, like aspect of chemical reactions, where we talk about hydrogen and its compound, chlorine and its compound, blah blah blah. So it's quite important that we understand these conceptions. So we'll be starting with ionic compounds. Now, when we are talking about ionic compounds, what comes to our mind are compounds that are majorly made up of two different or two oppositely charged ions. So in ionic compounds, we are definitely talking about a positive cations and a negative anion. So a positive ion and a negative ion coming together to form a neutral compounds, which are ionic compounds. So in any given ionic compounds, you have the cations and then you have the anion. So for example, when we are talking about sodium chloride, for example, how we are listening, everybody? Sodium chloride is made up of two major parts. We have the positive part, which is Na positive, and then you have the negative part, which is Cl negative. So this marks the two parts present in sodium chloride. So please, can you mute your mic, please? The person just joining. Can you mute your mic? Okay, let me do that on his behalf. It seems the person is not listening. Okay, thank you. Yeah. So I hope everyone is listening, right? Hello, am I talking?
Yes, sir. We
Okay.
are listening.
So every ionic compound is made up of two different parts. You have the positive part, the positive ion, and then you have the negative ion. So the positive ions are mostly the cat ions, so they are positively charged. So they are the cat ions, they are mostly metals. Okay. And then the anions are mostly what? negatively charged, and they are what? Non-metals. Okay. Now both come together to form a neutral compound called the what? Ionic compound. So there are ways by which we name ionic compounds, but one of the things that is most prevalent is that there is a need for us to first identify the common metals that we have and also know their charges, because that's the basis of this knowledge. Please, if you are doing anything, neglect what you are doing now, because this aspect is going to be very, very tricky. So if you don't get this aspect, you might not get our discussion again ever. So now, the first thing we need to identify are identification of metals. I might not talk in depth about their identification, but I will list some metals and I will tell you their cations and their charges. I mean, so identification of um, let's say metals or ions or what have you. Now, can you give me any example of metals that you are familiar with or you know? Anybody?
Magnesium.
Magnesium. Thank you. Mg. Any other one? There are so many. So
Sodium.
you tell me and you tell me their symbol, please. Sodium is Na. What else?
Aluminium.
Aluminium. The symbol is
Okay.
Al. Yeah. What else?
Potassium.
Potassium. That's K. Okay. Let me give you some
Okay.
of these metals. There are so many. Let me give you about a few of them that are very, very prominent that we are supposed to know. Everyone is supposed to know here. So we have calcium. This is Ca. Okay. We have what else? Lithium, which is Li. Okay, sorry, I'm putting the charge. It's not time for charge yet. So we have copper, which is Cu. We have iron, which is Fe. We have tin, which is Sn. We have lead, which is Pb. Please, anyone you don't know, let me know, because I'll be writing everyone that is very important. All metals that are important. We have silver, that is Ag. We have gold, that is Au. We have mercury, that is Hg. We have tin, that is, I mean, we
Sir,
have
what did you call SM?
Sn is tin. Okay, Sn is tin. We have Sc, that's scandium. We have Ti, that is titanium. Okay, we have V, that is vanadium. We have Cr, that is chromium. We have Mn, that is manganese. We have Co, that's cobalt. We have Ni, that's nickel. We have Zn, that is zinc. Okay, how many have I given? Can someone count that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, please sir, call me Alukozakios in, I think I've written iron, the tin, lead, okay. You can make some gold. Father, some, okay, okay. Okay, for now, these are the ones I can remember that are the major cations. Now, there are ways by which you can identify their charges, but we might not go through that route today. I want to force you to do something interesting. Out of your own time, after what you will do today, you need to go and study this, because it's the basis of what makes chemistry difficult for students. So these metals have their own cations, meaning their charges. So there is a need for you to know all the charges that are present on these ions, because they will be used in writing their chemical formula, the chemical formula of compounds, ionic compounds, or thereabout. Now, for example, let me start with elements which have what's it called, a charge of plus one. I mean, cations with a charge of plus one. I hope you are listening. Are we there?
Yes, sir.
So here are the cations that have a charge of plus one. So we have lithium Li, it is plus. Okay. We have C, I mean K, that's potassium, it is plus. We have Na, that's sodium, it is plus, sodium ion. Okay. We have we can have NH4 plus, that is ammonium ion. This is called ammonium. Please note the name that I'm writing. So Li is lithium ion, K plus is potassium ion, Na is sodium ion, NH4 is ammonium ion. It's not ammonia, it is ammonium ion. Okay, take note of that. Right, we have Ag, that is silver ion, it's always plus, most time plus. We have Hg, that's mercury, most time plus. Sometimes you can have Cu as plus. I hope you are listening. Okay, and we have H
Yes, sir.
plus. Okay, hydrogen ion is always H plus. Now these are common cations with oxidation number of plus 1. I hope that is clear. Now let's look at the cations with oxidation number of 2 plus. Are we there? Hello, can you hear me?
Yes, sir.
Yes, sir.
Okay, so we have beryllium. I don't know why this my pen is trying to disappoint today. We have beryllium is 2 plus. Let me use my hand then. Okay, we have Mg 2 plus. Okay, we have Ca 2 plus. I believe you know what I mean. This is beryllium ion, this is magnesium ion. Let me write that, Mg 2 plus. Okay, we have Ca2 plus, that's calcium ion, right? We have Fe2 plus, that is iron 2 ion. Okay, we have Sn2 plus, this is lead 2, this is tin 2 ion. We have Pb2 plus, this is lead 2 ion. Okay, we have Cu2 plus, this is copper 2 ion. Okay, what else do we have there? We have Zn2 plus, this is zinc 2 ion, common oxidation number. We have Ni2 plus, this is nickel 2 ion. Okay, now these are the common charges for, these are the common ions with
Sir,
a charge of 2
the
plus.
last one, what do you write?
Is Ni2 plus, that's nickel ion, nickel
Sorry,
2
sir.
ion.
Please,
Okay,
after the lead 2 plus,
yes, after
what
lead
is
2
the?
plus is Cu2 plus, that is copper 2 ion. We
So does
have,
it mean that copper can have plus
exactly,
one and
exactly,
plus one?
exactly. So some of these things have variable oxidation states, or they exhibit variable oxidation states. We're going to talk about them later. That's very good for your observation, so you can observe quite well. So we have some other metals also with a charge of 3 plus. Let's look at some of them. Okay, now the ones with a charge of cations with 3 plus. Okay, we have Fe 3 plus, it exists. Okay, so don't forget, we've seen Fe2 plus, we also have Fe3 plus, right? That's ion 3 ion. Okay, we also have Al3 plus, that's aluminium 3 ion. Or aluminium ion, is that clear?
Yes, sir.
So we can have some other ones, but those ones are not common, so I want to only emphasize those elements that have common oxidation states. So these are the ones we'll be working with. So from what we've seen, we've looked at the major ions with oxidation numbers, major cations or major metals with their oxidation number. So it is important that you know these charges. I don't know how you want to do it. You just have to sit and study it, because the reality is that students find chemistry difficult because of this very simple concept that we want to discuss today. Because you will always be talking about chemicals in chemistry, and so it is important that you understand how to name or write those chemicals in their appropriate formula. So what I have given now is just the charge for some of the common metals. Okay, So now we are going to move to the charge of some of the common nonmetals, right? So we will look at some nonmetals and then we are going to examine their charges. This is also quite important. So we have some of these nonmetals. Here we are talking about anions. So let's look at the anions. So we know anions are negatively charged. We have some of these compounds or some of these anions have their own special names. But before then, let's write some of them. So I want to write the general ones that are very, very prominent for that we often see in questions. Okay, so F minus. Okay, this is called fluoride ion. I will write the name later, but let me do that first. Cl minus. This is called chloride ion. Are we there? We have Br minus.
Yes, sir.
This is called bromide ion. Okay, we have I negative. This is called iodide ion. Okay, we have O2 minus. This is called oxide ion. Okay, we have N3 minus. This is called nitrite ion. I hope I'm not too fast. This is called oxide. This is called, I will still write their names. I'm just trying to write all those negative ions first that are very common in questions. Then we will look at how to work with them in naming compounds. So we have S2 minus. This is called sulfide ion. Okay, I believe I'm talking. So we have SO4 2 minus. This one has two names. It could be called tetraoxo sulfate 6 ion, or sometimes they call it sulfate ion. Okay, that is the SO4 2 minus. We have NO3 minus. This is called triazonitrate 5 ion. Sometimes they call it the nitrate ion, right? So we have ClO3 minus. This is called the triazochlorate 5 ion, sometimes called the chlorate ion. Please, I believe I'm talking.
Yes, sir.
We have the CO3 2 minus. This is called trioxocarbonate 4 ion, also known as the carbonate ion, right? So we have many more. We have PO4 3 minus. This is called the tetraoxophosphate 5 ion. How do we get all those names? We will talk about them lately while we are proceeding our discussion. Okay. Um, we also have SO3 2 minus. Okay, I will only want to limit myself on the common radicals because we can't exhaust everything. So we get to know more later as time progresses. Now, I believe this is understood. Now, I'm going to write some of them and tell you their specific names because that is what we are going to work on. Now, let's start. Now, let's start with F minus, as we said. We said this is called the fluoride ion. Fluoride ion. Please, are you taking notes? Then Cl minus. This is called the chloride ion. For those who are not writing, you are not doing yourself any good. Okay. Br minus. This is called the bromide ion. Okay. For I negative, this is called the iodide ion. So you observe one thing in all what I'm saying now. Look at this. You see that it is ending with IDE, 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 IDE because they are single negative anions. So fluorine, that is where fluoride is coming from because it's just one fluorine with a negative charge. This is chlorine, chloride, fluorine, fluoride, bromine, bromide, iodine, iodide. Is that clear?
Yes,
Then
sir.
N3 negative. So this is going to be nitride. nitride ion. So as you can see, O negative, O with a 2 negative will be what? Oxide ion. O negative will be an oxide ion. So you can see the trend of those single molecules, I mean those single anions, right, with their charges embedded. So if you proceed to, you also see the same thing in sulfide, S2 minus. This is called what? Sulfide ion with IDE. Sulfide ion. Please, can you put off your camera? We appreciate if you can put it off, please. Thank you. So the time when everyone will open the camera is coming. So for now, we don't want. Sometimes when everyone opens camera, is like a distraction for others. Others will not be looking at the class. It is another thing they will be looking for. So
Sorry, sir.
that's
Please, can you explain what you just explained
okay.
again? I
Which
don't
parts?
understand.
Which parts again? Now, are you? Do you understand what these ones are? Just the common anions that exist. These anions are negatively charged atoms that you must be familiar with and their charges. So in these ones now, there is no rocket science in this. There are things you need to sit and try to study on your own. For example, fluorine is an anion that has a charge of negative, F minus. Chlorine is Cl minus. Bromine, Br minus, and so on and so forth. Now once you know all these, one important thing again is that you must know how to name them. Now this F minus is not called fluorine ion. No, we call it what? Fluoride ion. This is why I'm trying to give their names. You can see that this F, that is the fluorine, and it is having a charge that is negative. We call it the fluoride ion. Cl, that is chlorine also, it is having a charge of minus. We call it the what? Chloride ion. That's the name, chloride ion. Bromine is negative, -1. Its own name is bromide ion. You can see as you are following the, if you follow the trend, you get to realize that their ending word is changing, right, to IDE, IDE, IDE. What's wrong with my mic? Is there anything wrong with my mic?
No, sir.
No, sir.
Okay, I was thinking somebody
No,
was
sir.
typing mic or something. Okay, what did you have to say? Somebody saying something. Please go ahead. I thought somebody was saying something. Can I continue?
Yes, sir.
Okay.
Yes, sir.
So you can see
Yes, sir.
nitride.
Yes,
Nitride
sir.
has
Yes, sir.
3 minus. So it is called the nitride ion. Nitrogen has 3 minus. Oxygen has what? 2 minus. Sulfur has 2 minus. So all these ones, they are ending with IDE, IDE, IDE because they are made up of just one single element that is what? Electrically charged, negatively charged. You get the point? So that is the first point you need to note. Apart from this, you have other ones which you said that you also need to know their names. Now in this case, you have to be very careful. For example, we have something like this, SO4. It has a charge of 2 minus. What is the name of this? This is called, you can see that this, how many oxygen do you have? 4 oxygen, so it's a tetra. So this is called tetra, right? Tetra means 4. Oxygen, oxo. Sulfur, sulfates. Now you can see here we are writing sulfates. We did not say sulfide because oxygen has been included. So this is tetraoxosulfate. Now you need to write the oxidation number of your sulfur. Then you put ion. Now the next thing is that this is tetraoxosulfate. What? You need to know the oxidation number of that sulfur. So how do we get to know that? It's very simple. Now I have my SO4 2 minus. Okay, I'm looking for the oxidation number of this sulfur. So how do I do that? From your basic chemistry knowledge, this sulfur is what I'm looking for. Let's say it is S plus, I know the oxidation number of oxygen from what we've just done up here. The charge on oxygen is 2 minus, so I will now put minus 2 here, minus 2, minus 2, because that's the charge on oxygen, minus 2. How many times does oxygen appear? Oxygen appears 4 times, so times 4. Are we together? Everything is now equals to, look at the charge on this compound, the charge on this ion I mean is minus 2, so everything will now be equals to what? Minus 2. Does that make any sense?
Yes, sir.
So then you are going
Sir.
to have sulfur plus minus 2 times 4, that is minus 8. Everything is equal to what? Minus 2. Therefore your sulfur will be equals to minus 2 plus 8. So what is sulfur now? Sulfur is 6. So it means that the name of this compound, I mean of this radical, is tetraoxosulfate 6 ion. So the oxidation number, I mean the oxidation number of sulfur here is 6. It must be written in Roman numerals and it has to be capital, not 6 as in VI like this. No, it has to be capital V, capital I. So that is how to name this. Now this compound, like you said, do I have cleaned this? I believe you understand what I mean. So let me do more so that you can get what
Yes, sir.
I am talking about. Now this compound is also known as, they popularly call it sulfates. Is a sulfate ion. Sulfate ion. You can see we didn't call it sulfide because it is having what? Oxygen. So whenever you hear sulfate, anything sulfate, it must contain what? SO4. You get my point?
Yes, sir.
Good. Now what if I have something like this? CO3 2 minus. Let me do that in the next slide. CO3, the charge is what? 2 minus. Now what is the name of this radical? This is called tri, okay, oxo, oxygen, right? Carbon, carbonate. Are you following the trend? Carbonate what? Carbonate dash ion. It's an ion because of the charge. Okay. Now trioxocarbonate something. Now what is that something called? We need to calculate the oxidation number of carbon also, like we did in the first one. This is a CO3 2 negative. You are looking for the oxidation number of carbon. So we say this is carbon plus oxidation number of oxygen, or the charge on oxygen is negative 2 multiplied by 3. So everything is equal to what? Minus 2. So this is going to be carbon minus plus minus 6 will be equals to minus 2. Therefore carbon is equal to minus 2 plus 6. Carbon will be equals to what? 4. So you can see this is trioxo, this is trioxocarbonate 4. So you write the 4 in here, IV. So this trioxocarbonate 4 is also called carbonate ion. They also call it the what? Carbonate ion. Carbonate ion. So whenever you hear anything carbonate, something carbonate, so what should come to your mind? CO3 with a 2 minus must be in place. Does that make sense?
Yes, sir.
Now if you have this NO3 negative, okay, NO3 negative, can anyone name this for me? Try to name it.
Trioxo nitrate 5 ion.
Trioxo nitrate
Very correct.
ion.
Trioxonitrate 5 ion. Trioxonitrate 5 ion. Okay. triazonitrate 5 ion. This is very correct. Now, this compound, how do we get to know that it's a triazonitrate 5 ion? Just follow the pattern like we did. So NO3 negative, we are actually looking for the oxidation number of nitrogen. So that will be nitrogen plus, okay, minus what? 2 times what? 3, everything equals minus 1. So that will be n minus 6, everything equals minus 1. So n equals minus 1 plus 6. So n equals what? 5. So that's why we have this as triazonitrate 5. It is popularly called what? Nitrate ion. Let me use another ink for that. We popularly call it the what? The nitrate ion. So whenever you hear anything nitrate, so NO3 negative should come to your mind. Understood? Now,
Yes, sir.
we also have
Yes, sir.
PO4 3 minus. We have the PO4 3 minus. Okay. Now, this one is called, yes, can you try the name of this? And the name of this. I want everyone to give it a trial. Try to give us what this one is and what this one is.
Tetra
Yeah, go ahead, please.
tetraoxo
Uh-huh.
phosphate
Uh-huh. Don't allow anybody to tell you. Say what is in your mind.
Tetrahydrophosphate 5 ion.
tetraoxophosphate ion.
Mm-hmm. Tetraoxophosphate 5 ion. Okay. Any contrary answer by others? Anybody with a contrary opinion? Okay. This is tetraoxophosphate. Phosphate because it's coming from phosphorus and it is having oxygen, so it has to end with ATE. Phosphate what? 5 ion. So if you calculate the oxidation number of phosphorus there, it's going to be 5. You can try that. So what will this one be then? And I want somebody to name these two.
Trioxosulfate
Tetraoxophosphate 4 ion.
Yes, this is a
4 ion.
trioxosulfate, right? 4 ion. Very correct. Now, what about this one? What about this IO3 negative? Somebody is saying I don't
Um,
understand. Who is that?
trioxo
Okay, continue please.
trioxo iodate 5 ion.
Yes, this is an iodate. Very correct. Trioxo iodate 5 ion. Very correct. Now, once you get this, then you are good to go to begin naming of simple ionic compounds. Now, if you are naming simple ionic compound, note we are going to start from the very simple ones. Then you'll be moving gradually to the complex ions. We are not dealing with complex ions at all. Complex ions is not in our syllabus. Okay, it's not in our syllabus for our level. So we have our IUPAC nomenclature of complex compounds too. When you talk about some what's it called? It's majorly in A level chemistry. So I don't want to bother us with that here. So now, when you want to name, let me start from the basics of naming ionic compounds. So we have some ionic compounds that have single radicals. For example, we've talked about this one with fluorine and so on and so forth. So what I'm going to do is I'm going to write the names and then we are going to write their chemical formula using their charges. Let me start from the simplest of them all, that is very common. Sodium chloride. Sodium chloride. Is everyone listening?
Yes, sir.
Yes, sir.
Sodium chloride.
Yes, sir.
Sodium chloride is an ionic compound. How do I know that it is ionic? Because it is made up of a metallic ion and a what? Non-metallic ion. So Na is metallic, it's a cation, and Cl is a non-metal. Now what is the charge on sodium? We've said it here that the charge on sodium, one of the things you need to go and study is that sodium has a charge of +1. You can see that. Can you see it? I hope you
Yes,
can see what
sir.
I'm showing. Yes. So
Yes, sir.
yes, so it means that here the charge on sodium here is +1, right? And the charge on chlorine here is what? -1. If you check there. So we now said we want to write the chemical formula of sodium chloride. What you do is you just exchange the charges. This positive one here +1 will come down here as a subscript, and this one also comes down here as a subscript. So this one becomes what? Sodium Na. You just neglect the charges, you only put the what? The number. This is 1 Cl1. So what have I done? I started writing the chemical formula of this compound by first writing the what? The positive ion. You can see I did not start from the negative, I started from the positive ion, which was Na. Okay, so and then I wrote their charges and exchanged their valencies, or their charges as the case may be. So I only wrote the number neglecting the charges. Sometimes they will call it valency, but it varies in some cases as some of these reactions. So I prefer using charges rather than using valencies. So just neglect their, what do we call it, neglect the charge, just put the numbers. Okay, so if it is 1, you just need to put NaCl. So this is called sodium chloride. Do you get the point? Why do we call it chloride? Because it's a single radical unit of chlorine, which is Cl negative, and we know Cl negative is a chloride ion. Na plus is sodium ion, so this is called sodium chloride. Does that make any sense?
Yes, sir.
Now if you have something like this,
Yes, sir.
magnesium chloride. Let's look at magnesium chloride. I want to focus on chlorine first before moving to others. Now for magnesium chloride, what are we going to do? We write magnesium first, and magnesium is Mg. What is the charge on magnesium, everybody? From those who have
+1.
never, like possible.
+2. +2.
Yeah, you
Plus
can you
2.
can see why learning those charges are very very important. In fact, the most important aspect of this course is to learn the charges. So after this class, if at all you still have challenges, that means you do not have any challenge. Your challenge is just to be able to know the charges. So magnesium has a charge of 2 plus. Now chlorine is a Cl. What's the charge on chlorine?
-1.
-1. God bless you.
Minus 1.
So then this two comes down here, and this one comes down here. So what are you now going to have? You are going to have Mg, right? The 1 is here, and Cl, the 2 is here. So the chemical formula of magnesium chloride is what? MgCl2. It's not MgCl, rather it is what? MgCl2. Does that make sense?
Yes, sir.
Can I
Okay.
Yes, sir.
Now,
sir, can I ask a question?
okay, go ahead please.
I thought chlorine was a
I didn't hear you, please.
sir.
Again.
Sir, yes. I thought chlorine was a diatomic molecule.
Chlorine was a diatomic. Yes, okay, fine. We'll talk about that later. Now, in this case, what are we talking about? We are actually referring to ionic compounds, not molecular, not molecular compounds, not covalent molecules. Okay? So, our objective here is to talk about ionic compounds, because when you say chlorine as a diatomic molecule, we are actually referring to that as a molecular compound. Do you get my point? But in this case, we are talking about when chlorine is reacting with metals. What is going to happen? We are majorly focusing on their
Okay, I
charges.
understand.
Good. So we get there because that is our goal. Our goal actually is to know how to write chemical equations and balance them easily. So irrespective of the chemical equation given to us, this aspect is going to assist us a lot in stoichiometry and several other aspects of chemistry. So that's why I've decided, okay, let me come to this aspect and let's take it as a fundamental. Okay, now if I'm having aluminum chloride, let's look at that. Aluminium chloride. So can anyone tell me the charge on aluminium?
3+.
Thank you. Aluminium is 3 plus. So it is Al. Sorry. So aluminium will be Al with a charge of what? 3 plus. Okay. Now Cl has a charge of minus. I think you have done that. So what do we do? Just exchange this. So that will give you what? Al1 Cl3. So aluminum chloride will be what? AlCl3. This is aluminum chloride. Does that make sense? Does that make sense, please?
Yes, sir.
Now note, there are some metals. They are particularly known as transition metals. When you are working with transition metals, let me see. Hey, my data. Okay. Still have about 1.2 gig. I think it should be enough. Now, when we are working with transition metals, okay, you must be specific about the oxidation number that is used. So what are the transition metals? Transition metals are metals, the common ones are metals between 21 to 30. Okay, those metals like, I don't know if you are very familiar with your periodic table, you should know the first 20 elements, right? Because it's not a beginner class. So I very much believe that you are familiar with the first 20 elements, isn't it?
Yes, sir.
Good. We have somebody is raising hand. Aisha, Aisha Karim. Do you have a question? I can see you raising your hand. Or is he an error?
No, no, no.
Okay, okay, okay. Now, those if you are dealing with those transition metals, you have to tell us specifically the oxidation number of the metal. You can see all what you have been doing. I did not mention their what. I just said aluminium chloride, kinikon sodium chloride, kinikon chloride, chloride. Now, but if you are dealing with transition metals, element from 21 to 30 for example, these are the common transition metals. What are the transition metals? The first rows transition metal. We have scandium. Are we there? Which is Sc. We have titanium. Are you listening?
Yes, sir.
Ti.
Yes, sir.
This is number 21. This one is number 22. We have vanadium. V. This is number 23. We have chromium. Cr. This is number 24. We have manganese. Mn. This is number 25. Can I continue? We have iron.
Yes, sir.
Fe. This is number 26. Can I proceed? Or some are still writing?
Yes, sir, you can proceed.
Okay.
Sir, I'm still writing.
Okay. Actually, there's an acronym I use for this thing. Maybe I should tell you the acronym. If the acronym always make me remember. I always use an acronym. Maybe after the class, I might tell you the acronym to remind me. So these are transition metals. The first row transition metals. Because you have three rows. We have first row, second row, and third row. But the first row are the common ones. Can I proceed?
Yes, sir.
Okay. Now the next one is cobalt. CO. That's 27. The next one is nickel. Nickel. Ni. 28. Copper. Cu. 29. Then zinc. Zn. 30. So this is 21 to 30. Now you can see all these transition metals you talked about, with the exception of zinc. All other ones you must tell us the specific oxidation number. I'll tell you what I mean. Can I proceed?
Yes, sir.
Yeah, for example, if I have this iron, let me write it this way, let me write it in another way. Since I was doing, I will write the compound, then I will write the this thing. So let me say iron 2 chloride and what, iron 3 chloride. You can see that we have iron 2 chloride, we have iron 3 chloride, but if I say iron chloride, I'm not specific, so iron chloride might not be correct because I did not specify the oxidation number. So because iron is a transition metal, so I need to specifically indicate what is the oxidation number of that iron. So if I'm talking about iron 2 chloride, what is going to be the chemical formula of iron 2 chloride? So iron 2, you have already said iron 2, so it means iron Fe has a charge of 2 plus. Then the chloride is a Cl negative, so this is going to be FeCl2. This is iron 2 chloride for this. Do you understand that?
Yes, sir.
But if it is iron 3 chloride, that will be Fe, a charge of what, 3 plus, then Cl negative, so this one will give me FeCl3. This is iron 3 chloride. You can see what I mean. Unlike the ones we are talking about, you can see this one, aluminum chloride. I did not say aluminum 3 chloride. You can see that I didn't say aluminum 3 chloride because aluminum is not a transition metal, it's just a normal metal. You get the point?
Yes, sir.
I did not say magnesium 2 chloride because magnesium is not a transition metal, it's just a normal metal. That's why it is magnesium chloride. I did not say sodium 1 chloride, I only said sodium chloride because sodium is just a normal metal, so that's why it is sodium chloride. But here we are saying it is iron 2 chloride or iron 3 chloride because iron itself is a transition metal. So I can have something like this, CuCl. Who will tell me the name of this compound?
Copper chloride.
That is wrong. Who can tell me why it is wrong?
Copper 1 chloride.
Copper 1 chloride is correct because copper is a what? Transition metal. So being a transition metal, this specifically tells us that the reason why this is the way it is because Cu is having a charge of plus, plus 1, and Cl has a charge of minus, and so in the formation it now led to what? CuCl, because the oxidation number of the copper here is plus 1, so that is why this is what? Copper 1 chloride. Please, you get what I'm explaining?
Yes, sir.
Now if
Yes, sir.
if you are having something like this, Cu Cl2. What do you think this will be?
Copper 2 chloride.
This will be copper 2 chloride. Very correct. Now, I hope this is clear. This is clear enough.
Yes, sir.
Good.
Yes, sir.
Now, so you need, whenever you are naming compound, you need ionic compound, you need to note if it is a normal metal or it is a transition metal, so that you know you are not going to fall into the wrong nomenclature or the wrong naming. So that is very, very important. Now, if you look at some other ions, you have talked about chlorine enough. Let's look at fluorine and others. It's just the same thing with others, but let me just mention few ones. So if I have this, sorry please, I don't know what this one is looking for here. Okay, so if I have, can anyone write for me the chemical formula of calcium fluoride? Or you want me to mention names? Please, everyone should participate. Calcium fluoride, what do you think would be the chemical formula of calcium fluoride?
CaFl2.
CaFl2. Is she correct? Is she correct?
No, sir.
I didn't hear you.
No, sir.
What is the correct one? If you think she's not correct.
CAF2.
CaF2.
CF2.
Yes. Fluorine is not Fl. Fluorine is F. You can see that. So this is not Fl. It is what? CaF2. Are we together?
Yes, sir.
Good.
Yes,
Yes,
sir.
And you
sir.
know how we came across this nomenclature. So now tell me the name of this compound. Aluminum oxide. I want to see how you are reasoning. Aluminum oxide.
ALO2.
Al2
Again.
Al2O3. Al2O3.
Al2O3. Very
ALO2.
correct. Eh? Somebody said ALO2. Did anybody say ALO2? Al2O3 is correct. Yeah, I believe some people said that. Al has a charge of what? 3 plus. Why oxygen has a charge of what? Minus 2. So what do you need to do? Just exchange the radicals. This comes down here. This comes down here. So what will this give us? Al2O3. That is aluminum oxide. Does that make sense, please?
Yes, sir.
Good. Now, can anyone give us the chemical formula of um let me see. Okay, this magnesium sulfide. Magnesium sulfide.
Mg2O2.
Mg2S2.
Again. Mg
Mg2S2.
Mg2S2.
S3.
Now, Mg2S2, these two can cancel out. This one will cancel this, and it become what? Mgs. So magnesium
Mgs.
sulfide is what? Mgs. Do you get it?
Yes, sir.
Yes, sir.
Now, what would be the chemical formula for iron 2 nitride? Iron 2 nitride. Iron 2 nitride.
F
Again,
Fe three
Fe3,
N
and
two.
2. Very correct. Fe3 and 2. Very correct. This is iron 2 nitride. Understood by everyone?
Yes, sir.
Now, you are going to,
Yes, sir.
if you have not been checking the valencies, that means you are super good. But if you are still checking the valencies before you can do it, well, that means you need to go back and master those charges very correctly. Is that okay? Is that clear?
yes, sir. Please
Yes,
continue.
sir.
Now, next, let's now look at the carbonate. Now, whenever you are writing chemical formulas that are made up of radicals, that is a group of atoms that are electrically charged, for example with a CO3 2 negative. So let's look at some compounds like that. We can have Na and what? CO3. Are you following? We know that the sodium here has a charge of what? Plus. And the CO3 has a charge of what? 2 minus. We know the name of CO3 is triazocarbonate 4 ion, isn't it? Or we call it carbonate. And Na has a charge of plus. So to write the chemical formula of something like this one comes down here and this two comes down here. So this becomes Na2 and the CO3. Because it is just one, I don't need to put it in brackets. Okay, even if I put it in bracket, it's still the same thing. So I'm going to have Na2CO3. Does that make sense? Now, this compound, how do we call it?
Yes, sir.
This is called sodium because you are starting with the sodium. Sodium trioxocarbonate what? Carbonate 4. You don't need to put ion there because it's no more an ion. It is now a neutral compound because positive and negative are come together to form a neutral compound. Is that clear?
Yes, sir.
Yes,
Let me
sir.
go
Sir.
up here. Let me go up here. Okay. Let me clean this. Few seconds, please. So I can have something like this. Aluminum. Okay. Let me use aluminum here. Let me use calcium trioxocarbonate 4. Now, if I'm told to write the chemical formula for this, for example, calcium triazocarbonate 4, I know calcium has a charge, Ca, charge of 2 plus, triazocarbonate ion. So a triazocarbonate 4 ion is CO3, then 2 minus. Can you see that? So if you don't master the charges, is a problem. So this comes down here, this comes down here. So this will give me Ca2, right? CO3 into bracket 2. Don't use these 3 that will multiply what is inside the bracket. Oh. These 2 and these 2 can cancel out. So this becomes CaCO3. This is called calcium triazocarbonate 4. Now this calcium triisocarbonate 4, sometimes you can call it calcium carbonate. So because we said the CO3 2 minus is also known as what? Carbonate ion. So don't be surprised when you hear calcium carbonate. Although that's not an IUPAC name, but it's sometimes used very frequently in some questions. So calcium triisocarbonate 4 is CaCO3, popularly called limestone. So it is also calcium carbonate. I guess that's understood. Is that understood?
Yes, sir.
Yes, sir.
Yes,
Now,
sir.
can you write the chemical formula of potassium triisocarbonate 4? Potassium triisocarbonate 4. Potassium triocarbonate 4. Potassium triisocarbonate.
K2
K2,
O3.
CO3. Very correct. K2CO3. Very correct. Potassium triisocarbonate 4. Now, who will write for us the chemical formula of iron 3 trioxocarbonate 4? Iron 3 trioxocarbonate 4. Iron 3 triosocarbonate 4.
Fe2.
Fe
Fe2
Fe2 plus
Fe2
CO3
C2O6.
oh my
CO3
god
CO3 3. I heard somebody saying
Yes.
6. You don't use this. I've said it. You don't multiply with anything. Oh, you don't multiply with anything. So they cannot cancel out. So it remains this Fe2CO33. This is iron 3 trioxocarbonate 4. I guess that's understood.
yes
Okay?
sir
Yeah.
Yes, sir.
yes sir
Okay. Now let's move on to other ones like phosphates and chlorates because the time is going very fast. We might not be able to do. Ah, okay, let's see, if I can touch on what have you. That one is not very much. Now, for example, I have magnesium, right? Phosphates. Magnesium phosphate. Who will try that? Magnesium phosphate.
Mg3
Mg3,
PO4
PO4. Is that?
yes sir
Okay. Any contrary answer?
Yes.
Okay, go ahead.
Mg3
Mg3
bracket
bracket
PO4
PO4
Close bracket
close
2.
bracket 2. Yes, this is correct. Now, do you know why you made an error here? Have you seen your mistake for this?
Yes, sir.
What is your mistake?
It's MG 2 plus.
Exactly. So mg is 2 plus. So mg 2 plus. And po4 is what? 3 minus. Can you see how important those charges are? So that is the priority of all what you are doing for today. Okay. So and we know this is also called what? The IUPAC name gongon is magnesium, right? Tetra oxo phosphate phosphate what? 5 tetraoxophosphate 5. So that's the name also. Apart from calling it that, the IUPAC name is magnesium tetraoxophosphate 5. Is that understood? Now, that is that. So quickly, because of the time, let us learn how to name some molecular compounds. There are some molecular compounds, those ones too, they have their own rules. But I will just tell you some basic fundamentals about it so that we can use them to name compounds. So, molecular compounds. So we are talking about covalent compounds here. So let's start from. Okay, let me start. When you get to reactions, we talk about the ones somebody raised. So, but for now, let's just talk on the basic conceptions. So now, if I have, there's a lot of compounds that are very common that we even know their nomenclature. So let's start from the CO2. Now, to name compounds like this, because you are dealing with non-metals, it is not metal and non-metal. So it is non-metal and non-metal combining together, binded together by covalent compounds, right? I mean covalent bonds. So if you are naming things like this, you have a special way of naming it. So you can either calculate oxidation number, right? Or you can also use your what? The number of repeated atoms. For example, this one is popularly called carbon. Are we together? How many oxygen do we have here? Two. Because you have two oxygen, it's going to be di. So this is carbon dioxide. Are we following?
Yes, sir.
Yeah.
Yes, sir.
So
Yes, sir.
or we
Yes, sir.
calculate the oxidation number of the carbon. So how do we do that? We say carbon, they are looking for the oxidation number plus oxygen. We know oxygen is negative 2. It's appearing how many times? 2 times. So that's times 2. Everything is equal to what? 0. So this will give us carbon minus 4. Everything equals to 0. So carbon equals what? 4. So another name for this is what? Carbon 4 oxide. You get it? So in this case, we are actually using the oxidation number of carbon. Actually, the main IUPAC nomenclature is the second one, but prominently you can see the first one also a lot in questions. So that's why I'm also referring to that. I hope that is clear. I believe everyone
Yes.
understand what I have
Yes,
done.
sir.
Okay. So
Yes, sir.
it
Yes,
means
sir.
that if I have something like this, CO, can anyone tell me what the name of CO would be? Let me quickly clean this.
Carbon.
Yes, go ahead. CO.
Carbon oxide.
Carbon what?
Carbon oxide.
Carbon
Carbon monoxide.
Carbon dioxide
carbon monoxide. Mono
or
because
carbon
you have
monoxide.
just one oxygen. So one is mono. Mono oxide. Carbon monoxide. Or we call it what? Carbon 2
Carbon two.
oxide. Why do we get the 2? Calculate the oxidation number of carbon here. It will give you 2. That's carbon plus oxygen is negative 2 times 1, right? Everything equals to 0. So that will be carbon minus 2 equals 0. So carbon equals what? 2. So the oxidation number of carbon here is 2. So that's why it is carbon 2 oxide. Is that clear, ladies and gentlemen?
Yes, sir.
Now, if you look at this, SO2, you can see that I'm calling the name of the compound itself because I did not say sulfide because here there is no positive ion, so it is still sulfur, so this will be called sulfur dioxide. You get it? Or we call it what? Sulfur. You calculate the oxidation number of this sulfur, that will give you 4. If you do that, sulfur 4 oxide. Does that make sense, please?
Sir.
Yes, sir.
Yeah, go ahead. Okay, I was thinking somebody
No,
was
I
saying
said
something.
yes, sir.
Okay, okay, okay. Because later I will tell you how to transform these things like this, maybe next week. How to transform things like this back to their chemical formula. But for now, let us do it this way. Because I want us to solve some questions before we end. So if you have something like this, SO3. So what will be the name of this?
Sulfur trioxide,
Very
and sulfur
correct.
6 oxide.
Very, very correct. Sulfur trioxide or sulfur 6 oxide. Does that make sense? Everybody?
Yes, sir.
Yes,
Yeah.
sir.
Now, what if
Yes,
you have
sir.
this? What if you have this? N2O4. Anybody? N2. I want to see who will try this. N2O4. Yes.
Nitrogen 4 oxide.
Nitrogen 4 oxide. Mm.
Or nitrogen tetraoxosulfate.
Nitrogen tetraoxosulfate. No, that one is not correct because you use tetraoxosulfate. There is not even a sulfur there. So, and you don't use that here because it is not. There is no positive ion.
Sorry,
So,
sorry.
uh,
Tetraoxonitrate.
tetraoxonitrate.
Tetraoxonitrate 6 oxide.
Now we don't use nitrates except for when you have what? NO3 minus. So that one does not exist here. Now this is how you know the reason why I brought it this is because the person the answer said by the first person is correct. But another way we can name it, you see this nitrogen is two nitrogen, so we can call it dinitrogen. Give me a few seconds, please. Few seconds. Hello, are you paying attention? Now this is dinitrogen because don't forget in this case we are dealing with non-metals. So for non-metals you can name the number of repeated atoms in the given compound. In this case now you can say this is dinitrogen and this is what? How many oxygen? 4. This is tetraoxide. So we can call this dinitrogen tetraoxide. Do you get my point?
Yes, sir.
Yes, sir.
So
Yes, sir.
like somebody said, this is a dimer. So you can also say this is going to be nitrogen 4 oxide like somebody said, but it's going to take the same format with NO2. If you calculate the oxidation number of this nitrogen, it will be 2n plus minus 2 times 4. Everything equals to 0. So that will be 2n minus 8 equals to 0. That will be 2n equals to 8, n equals to 4. So if you say nitrogen 4 oxide is still not out of place anyways, but this is the real nitrogen 4 oxide, but because it forms a dimer, so that is why we can take it out 2 as the compound. So um with that logic that I've just explained, okay, can you name this compound here? Sorry. P4H10 and P2O5. Yes. Anybody? I want to see who will think very smartly to give us this. Yeah, go ahead, please.
Tetra
Uh-huh.
tetraphosphorus
Good.
decahydrogen. Ah,
Deca what? Is hydrogen, oh.
decahydrogen.
Hmm. It is okay if it's
Tetra.
if it is wait. If it is the first one we did, what did we do? What did you say? Did you say dinitrogen tetraoxygen? Did we say dinitrogen tetraoxygen? What do you say?
No,
You said dinitrogen what?
dinitrogen
Tetraoxide.
tetraoxide.
Oh
Okay,
yeah,
so that one will be
use the same logic for that one.
tetraphosphorus
Uh-huh.
decahydride.
Decahydride. God bless you. That is it. Decahydride. Is that clear to everyone?
Yes, sir.
Okay. If you like, you can also calculate the oxidation number. It's fine. What about the second one? P2O5.
Diphosphorus
Uh-huh.
pentaoxide.
Very correct. Diphosphorus pentoxide. Diphosphorus pentoxide. So we have little time left. Let me see if I have some questions here. Nomenclature. Few seconds, please. Let me quickly check. I think I should have some. Give me a few seconds. Let me check this. I want you to have. Okay, is it I guess it should still be here. Okay, it's not here. Let me check. Few seconds, please. I'm trying to. Okay, let's quickly go online. Let me check some questions online, please. I know I downloaded
Sir,
some, but I can't remember. Yeah,
sir, please, I have one question.
go ahead, please.
The P4H10, if you
Yes.
find the oxidation number of P, is going to be, from what me I'm getting, is 5 over 2.
Okay.
So, how will you name it if you use
So compounds like that, you don't prefer it exactly. So that is why compounds of that nature that used to have decimals as their what's it called oxidation number, you prefer to name them using that logic that I told you rather than using what decimals. You understand?
it? Okay.
Yes.
Yes, sir.
Nomenclature of inorganic worksheets. Few seconds. It's already time, sef. But let me see worksheets. I know I've done something like that before, but I can't remember where I got. Okay, I have one here. Let me see if this one. I don't know what is here, but let's see. Oh, this one is too simple. Okay, let me download this then. Okay, so let's take like 5 minutes to look at this. Okay, now these are very simple ones, so I don't think. Now look at write the symbol for the following cations. So what's the symbol? Sodium. Yeah, quickly, quickly, quickly. Let's be fast about this one. Sodium is what?
Na
Na plus. Na plus.
plus.
Potassium is what?
Okay.
Ca2 plus.
Ca2 plus. Copper is what? Copper 2 is what?
Cu2 plus.
Cu2 plus. Aluminium is what?
Al3 plus.
Al3 plus. Iron 3 is what?
Fe3 plus.
Fe3
Okay.
plus.
Zinc is what?
Zn.
Zn3
Zn2
plus.
plus.
Zn2 plus. Potassium
2 plus.
K minus.
K
K
plus. K
plus.
plus. Silver
Oh, sorry, K plus. K plus.
Ag plus.
Ag plus. Magnesium
Mg2 plus.
and
Mg2
so on and so
plus.
forth. So let's
Mg2
look at this
plus.
one. Chloride, chloride, chloride.
Cl minus.
Cl minus.
Chloride. Cl
Bromide,
minus.
bromide.
Br minus.
Br minus.
Iodide.
Cl minus.
I
I
minus.
minus.
Yes, sulfide.
I minus.
Minus.
S2 minus.
S2
S
minus.
minus.
Oxide, oxide.
S2 minus.
O2 minus.
O2
O2 minus.
minus. This is sulfate.
SO42 minus.
SO42
SO42
minus. It's same thing
minus.
as sulfate 6 ion. Now sulfites. This one is having Te. This one is having Te. Sulfites. Okay. Anybody with this? Oh yeah, go and look for this. Everybody, I'm not telling you. Go and look for it. When we say sulfites, what do we mean? Okay. The ones that end with the ones that end with ite. So go and look for their general way or route of writing them. Now nitrate. What is nitrate?
N3.
Nitrate. NO3 minus.
NO3 minus. Yes, it's a triazonitrate 5 ion.
And
Then hydroxide. I didn't say hydroxide. Hydroxide is OH minus. Hydroxide is OH minus. Sulfate, we know that's PO43 minus. We've done chlorate, ClO3 minus, right? And so on and so forth.
Yes.
Yes, sir.
Go and look for others. Now, these ones are very easy. CO, what is the name?
Carbon dioxide.
Cobalt.
Carbon monoxide.
Carbon monoxide or carbon 2 oxide. CO2. Some yes,
Carbon
look
4
at
Carbon
this.
oxide.
dioxide.
There is difference between capital C, capital O, and capital C and small o. When it is capital C, capital O, that is carbon monoxide or carbon 2 oxide. But when it is capital C, small o, that is cobalt. They are not the same thing. Oh. You can see this is capital C, capital O. This is carbon monoxide.
Yes, sir.
Good. Now, this one is CO2. What is this called?
Carbon 4
Carbon
oxide.
4 oxide.
Carbon 4 oxide. What
carbon
about this one? Yes, it's also carbon dioxide. It's also carbon 4 oxide. Yes. What about PBr5?
Is that R?
Yes. PBr5.
phosphorus,
Yes.
pentabromide,
Yes. Phosphorus pentabromide. Correct. SO2. What is that?
Sulfur 4 oxide.
Sulfur
sulfur
4 oxide.
oxide,
Yes. SO3.
sulfur
Sulfur
6
Sulfur six
trioxide.
oxide,
oxide.
Sulfur 6 oxide or sulfur trioxide. Correct. What about Cl2O7?
di dichlorine
Dichloro.
No,
heptaoxide,
it's
Dichlorine.
not dichloro.
dichlorine
Yes.
heptaoxide.
Dichlorine.
Dichlorine
Sorry,
heptaoxide.
dichlorine heptoxide.
Yes. You can also calculate the oxidation number of the chlorine there. You are good to go. Either of the two. H2S.
Dihydrogen
Hydrogen
sulfide,
Very correct.
H2S.
sulfide.
Dihydrogen sulfide. Sometimes they always call it hydrogen
Sulfide.
sulfide. So it's also dihydrogen sulfide. NH3.
Dihydrogen sulfide.
Yes.
nitrogen trifluoride,
NF3 is tri what? Nitrogen trifluoride. Yes, correct.
Nitrogen
nitrogen
trihydride.
Now
trifluoride,
N2O5. What is that?
dinitrogen pentoxide,
Yes, very correct. Now
Pentaoxide.
Nitrogen
let's look at that. Name the
pentoxide.
following IUPAC compounds. CuCl2.
Copper.
copper 2 chloride,
Copper 2 chloride. Correct. Fe bracket OH3.
yeah?
This
Fe
is
open
starting now,
bracket
serious.
OH3.
Drag my this thing now. Let's drag it. Use your
Iron 2 oxide,
Eh?
iron 1 no, iron 3
Yes,
hydroxide.
very correct. Iron 3 hydroxide. I've told you that OH is hydroxide. So iron is a transition metal. So that will be iron 3 hydroxide. Okay. What is FeO?
Iron 1 oxide,
Iron.
No.
No, it's not iron 1. No.
One oxide.
How can it be iron 1? What's the
Iron
oxidation?
ox.
What's the oxidation number on the iron? And what's the oxidation number of oxygen?
iron 2 oxide,
It should be iron 2 oxide
iron 2
because
oxide.
Fe2 plus O2 minus. So they will cancel each other. So that's why it is FeO. So that is iron iron 2 oxide. Now I will give you this for you to go over it. Anything that is not clear, you can see they've given you the solution to all of them. So anything that is not clear, then you can, because in our next discussion what we'll be doing is we'll be looking at chemical reactions. How do we write simple chemical reactions? I haven't learned all these things, so we want to apply it to writing chemical reactions. So hopefully we'll do that next week. So we are going to stop here. Do you have any question? Any question? No question. So if there are no questions,
No,
we
no
sir.
stop
sir.
here, and then we meet again in the next class.
Sir,
Have a
you
nice
said
day.
you give us the acronym of
Oh, the
those
acronym. Oh yeah, let me, for those that are interested, let me say it. If you can write it. Oh, let me write it here. So the acronym for the first, for the transition metal, the first series of transition metals. So science, this is the acronym I always use. Science teaches verdict. Science teaches verdict. Okay. Coil, coil masters. Coil masters in Congo. In Congo need need copper, zinc. So that is the, so science, this one, this stands for scandium,
candidates.
science titanium, vanadium, chromium, manganese, iron,
Iron, cobalt,
cobalt, nickel,
nickel,
copper, and zinc. So these are the first series of transition metals from 21 to 30. Is that okay?
Yes, sir.
So let's stop here. Have a nice day. We meet again in our next class.